Everyone, my name is Nikita. I am from ECE branch. My subject is electrical circuits and my topic is mesh analysis. What is mesh analysis? Mesh analysis is defined as the method in which the current flowing through a planar circuit is calculated. A planar circuit is defined as the circuit that are drawn on the plane surface in which there are no wires crossing each other. Therefore, a mesh analysis can also be known as loop analysis or mesh method. Mesh analysis is a method that is used to solve planar circuits for the current at any plane in the electrical circuits. Planar circuits are the circuits that can be drawn on a plane surface with no wires crossing each other. A more general technique called loop analysis can be applied to any circuit, plane or not. Mesh analysis and loop analysis both make us of Kirchhoff's voltage law to arrive at a set of equation guaranteed to be solvable if the circuit has a solution. Mesh analysis is usually easier to use when the circuit is planar compared to other loops. What is branch? Branch is defined as a path that connects two nodes such that it contains a circuit element. If the branch belongs to only one mesh, then the branch current and the mesh current will be equal to each other. The node method. The voltage is always defined as the potential difference between 2 points. When we talk about the voltage at a certain point of a circuit, we imply that the measurement is performed between 2 points and some other point in the circuit. In most cases, that other point is referred to as ground. The node method or the node voltage method is very powerful approach for circuit analysis, and it is based on the application of KVL and KCL and Ohm's law. The procedure for analyzing a circuit with the node method is based on the following steps. Clearly label all the circuit parameters and distinguish the unknown parameters from the known. Identify all nodes of the circuits. Select a node as a reference node, also called the ground, and assign to it a potential of 0 volts. All other voltages in the circuit are measured with respect to the reference node. Label the voltage at other nodes. Assign the label polarities. Apply KCL at each node and express the branch current in terms of the node voltages. Solve the resulting simultaneous equations for the node voltage. Now that the node voltage are known, the branch current may be obtained from Ohm's law. The third step is to select one of the identified node as a reference node. We have 4 different choices for the assignment. In principle of any these node may be selected as the reference node. However, some nodes are more useful than other. Useful nodes are the one which makes the problem easier to understand and solve. There are few general the one which makes there are few general guidelines that we need to remember we as we make the selection of the reference nodes. A useful reference node is one which is the largest number of elements connected to it. A useful reference node is one which is connected to the maximum number of voltage sources. Place all sources on the right hand side of the equation as inhomogeneous drive items. The term comprising each element on the diagonal of matrix A must have the same sign. If you arrange so that all diagonal elements are positive, then the off diagonal elements are negative and the matrix is symmetric. So the node voltage method provides an algorithm for calculating the voltage at the node of a circuit, provides one can specify the connectivity of element between two nodes. then one can write down a set of simultaneous equation for the voltage at a node. Once these voltages has been solved for, then the circuit are calculated via Ohm's law. Procedure of mesh analysis. The following steps are the followed while solving the given electrical network using mesh analysis. Step 2. To identify the mesh analysis and label these mesh current in either clockwise or counterclockwise direction. Step 2. To observe the amount of current that flows through each element in terms of mesh current. Step 3. Write the mesh equation to all meshes using Kirchhoff's voltage law and then Ohm's law. Step 4. The mesh current are obtained by following step 3, in which the mesh equation are solved. Hence, for a given electrical circuit, the current flowing through any element and the voltage across any element can be determined using the node voltages. Mesh current voltage. Mesh current analysis. An easier method of solving the above circuit is by using mesh current analysis or loop analysis, which is also sometimes called Maxwell's circulating current method. Instead of labeling the branch current, we need to label each closed loop with the circulating current. As a general rule of thumb, only label side loop in a clockwise direction with circulating current, as the aim is to cover all the elements of a circuit as at least once. Any required branch current may be found from the appropriate loop or mesh current as before using Kirchhoff's method. For example, I1 is equals to I2, I2 is equals to minus I1, and I3 is equals to I1 minus I2. We now write Kirchhoff's voltage law equation in the same way as before to solve them, but the advantage of this method is that it ensures that the information obtained from the circuit equation is the minimum required to solve the circuit, as the information is more general and can easily be put into a matrix form. Write Kirchhoff's voltage law equation is the same way as before to solve them, but the advantages of this method is that it ensures that the information obtained from the circuit equation is the minimum required to solve the circuit, as the information is more general and can easily be put into a matrix form. Example: find the voltage across 30 ohms resistor using mesh analysis. First we do step 1. There are two meshes in the above circuit. The mesh currents I1 and I2 are considered in clockwise direction. Those mesh currents are shown in the figure. Step 2. The mesh current I1 flows through 20 volts voltage source and 5 ohms resistor. Similarly, the mesh current I2 flows 30 ohms resistor and 80 ohms voltage source. But the difference of two mesh current I1 and I2 flows through 10 ohms resistor, since it is common branch of two meshes. Step 3. In this case, we will get two mesh equations since these are two mesh in the given circuit. When we write the mesh equations, assume the mesh current of that particular mesh as greater than all other meshes currents of the circuit. Here is the equations I wrote about this problem. Step 4. Finding mesh currents I1 and I2 by solving equation 1 and equation 2. The left hand side terms of equation 1 and equation 2 are the same, hence equate the right hand side term of equating 1 and equation 2 in order to find the value of I1. A mesh analysis works by arbitrarily assigning mesh currents in the essential meshes. An essential mesh is a loop in the circuit that does not contain any other loops. Figure 1. Label the essential meshes with 1 or 2 and 3. A mesh current is a current that loops around the essential mesh and the equation are solved in terms of them. A mesh current may not correspond to any physically following currents, but the physically current are easily found from them. It is usual practice to have all the mesh currents loops in the same direction. These help prevent across when writing out the equation. The convention is to have all the mesh currents looping in a clockwise direction. Solving for mesh current instead of directly applying Kirchhoff's current law and Kirchhoff's voltage law can be greatly reduce the amount of calculation required. This is because there are fewer mesh current than any physically branch currents in type. For example, there are 6 branches currents but only 3 mesh currents. Mesh current analysis. An earlier method of solving the above circuit by using mesh current analysis or loop analysis, which is also sometimes called Maxwell circulating current method. Instead of labeling the branch currents, we need to label each closed loop with a circulating current. Only with KVL and KCL principle, the analysis turns out to be inaccurate and not re- reliable too. So, to go with exact analysis and to know the variable in those circuits, approach like mesh and nodal has to be implemented. With those methods, variables such as current and voltage can be known as early variable is known as easily. Loop mesh analysis. Loop mesh analysis is a systematic application of KVL around various loops in a circuit. The KVL equation are written in terms of loop current common to all elements in a loop. The result will be a system of equation in which the unknowns are these loops currents. The solution of this equation will therefore yield values for the loop current. For the circuit in figure 1, apply mesh analysis to solve the mesh current I1 and I2. Report your answer in milliamps. You must follow and document all steps in learning module to receive full credits. Calculate the voltage difference across the 30 ohms resistor in the center of the circuit. Which node connected to the 30 ohms resistor have the greater node voltage? Label the voltage drop polarities. The next step is to label all the voltage drop polarities across resistors according to the assumed direction of the mesh currents. Remember that the upstream end of the resistor will always be negative and the downstream end of the resistor will always be respective to each other. Since electrons are negatively charged, the battery polarities of course are dictated by their symbols orientation in the diagram and may not agree with the resistor polarities assumed current direction. Using Kirchhoff's voltage law, we can now step around each of these loops, generating equation representative of component voltage drop and polarities. As with the branch current method, we will denote a resistor voltage drop as the product of the resistance in ohms and its respective mesh currents. Where two currents mesh together, we will write the term in the equation with resistors current being the sum of two meshing currents. Advantages of mesh current analysis. The primary advantage of mesh current analysis is that it generally allows mesh analysis works by arbitrary assignment to mesh current in the essential meshes. An essential mesh is a loop in the circuit that does not contain any other loops. The essential meshes with 1, 2 and 3. A mesh current is a current that loops around the essential mesh and the equation are solved in terms of them. A mesh current may not correspond to any physically following currents, but the physically current are easily found from them. It is usual practice to have all the mesh currents loops in the same direction. This helps prevent error when writing out the equation. The convention is to have all the mesh current looping in a clockwise direction. Solving for mesh current instead of directly applying Kirchhoff's current law and Kirchhoff's voltage law can greatly reduce the amount of calculation. These are physically branch currents. In type, for example, there are six current branches on and but only three mesh currents. But the advantage of this method is that to ensure that the information obtained from the circuit equation is the minimum required to solve the circuit, as the information is more general and can easily be put into a matrix form. And only with the KVL and KCL principle, the analysis turns out to be in, inaccurate and not relatable to. So it go with the exact analysis and to know the variable in those circuits. Approach like mesh and nodal to be implemented with those methods variables such a current and voltage can be known as easily. Advantages of mesh current analysis. The primary advantage of mesh current analysis is that it generally allows for the solution of a large network with fewer unknown value and fewer simultaneous equation. Our example problem took three equations to solve the branch current method and only to solve equations using the mesh current method. This advantage is much greater as network increases in complexity. To solve this network using branch currents, we'd have to establish five variables to account for each and every unique current in the circuit. This would require five equations for the solution in the form of two KVL equations and three KVL equations, two KCL equations and three KVL equations, two equations for KCL at node and three equations for KVL at each node. Thank you.